Okay, students. So let's get started with the past papers of O levels in IGCSE physics for the chapter of light and lenses. So let's see the first MCQ. Which characteristics describe the image formed by a vertical plane mirror? Okay. So there are three characteristics that you need to remember for an image formed by a vertical plane mirror. Firstly, it is virtual. Secondly, it is upright. And thirdly, it is the same size as the object. So the image formed from a plane mirror is virtual, upright, and same size as the object. B is your answer. Let's further move ahead. The diagram shows two divergent rays of light from an object at O. So this is your object at O being reflected from a plane mirror. Okay. At which position is the image formed? Okay. So what have we studied? The image, the perpendicular distance, you can say the perpendicular distance of image from the mirror, of image from the mirror is the same as what? The perpendicular distance of the image from the mirror is equals to the perpendicular distance of the object from the mirror, of the object from the mirror. Simple. Now, if you closely look at it, the perpendicular distance, one second, let's pick this up here and let's place it here. Okay. So the perpendicular distance of the object from the mirror, that is this line, will be the same as the perpendicular distance of the image from the mirror. B is your answer. Let's further move ahead. Let's look at this. Light is incident on a mirror and is reflected as shown. Okay. And as you can see here, I don't know whether you can visualize this or not, but if you closely see here, this is a line. This is a line. An angle on a straight line. Complete angle on a straight line is equals to 180 degree. Okay. And you know this portion is equals to 80 degree. And you know this portion is equals to 80 degree. What will be the remaining portion? 180 minus 80 degree is equals to 100 degree. Now you know this is the angle of incidence, this is the angle of reflection. Both of them will be equal. 100 is equals to angle of incidence plus angle of reflection. And we know that angle of incidence is equals to angle of reflection. Now substitute it here. 100 is equals to I plus I. 100 is equals to 2I. Angle of incidence is equals to 50. And angle of reflection also equals to 50. D is your answer. Let's look at this. A mirror is placed in the path of a ray of light. Okay, so this is the mirror. Through which angle does the direction of the ray of light change? Okay. So through which angle does the direction of ray of light change? Okay. So if the mirror wasn't present, your light would have gone like this. If the mirror wasn't present, the light would have gone straight through like this. But now your light is getting reflected like this. What is this angle? What is the direction change? What is this x? Can you calculate it? Yes. If you notice, this is the angle of incidence. This 40 degree is the angle of incidence. This angle of reflection will also be 40 degree. And we know that angles on a line are equal to what? 180 is equals to 40 plus x. X is equals to 180 minus 80, that is equals to 100 degrees. C is your answer. Let's further move ahead. Light reflects from a plane mirror as shown. Okay, light is incident from here. This will become your angle of incidence. This will become your angle of reflection. Which row is correct? Okay. Symbol for the angle x. So we know angle x is angle of reflection. So it will be either C or D. A and B gets cancelled out. And we also know x will be equal to y. C is your answer. Simple as that. Let's further move ahead. A plane mirror on a vertical wall forms an image of an object placed in front of it. Which characteristics describes the image? Okay. So basically, a mirror, a plane mirror, sorry, is forming an image. And in the start of the lecture, I have told you what are the three characteristics of an image formed by a plane mirror. Virtual, upright, and same size as the object. D is your answer. Let's further move ahead. An object O is placed in front of a plane mirror. Okay. I is the image formed. Okay. So this is the object, this is the image formed. Okay. A ray from the top of the object is incident on the mirror at x. Okay, so somewhat like this. A ray from the top of the object is incident like this. Okay, now, okay, what will happen? What happens through this? Sorry, what happens through this ray? Sorry for this direction. What happens through this ray? What will happen to this ray? This ray we know will get reflected in such a way that it appears that it is getting reflected of the top of the image, that it is getting reflected of the top of the image. Let's see if we have any answer like that. It reflects as it comes from the bottom of eye. No, A, B, C can't be my answers. It reflects as though it comes from the top of eye. This is what I said. Your image key reflected ray will come from the top of the image like this. Let's move on to the next question. An object is placed at a distance from a converging lens that is equals to twice the focal length. Okay, so it is placed at 2f. Which statement about the image is correct? It is enlarged? No. It is on the same side of the lens? No. It is virtual? No. It is inverted? B is your answer. Let's see this. The diagram shows light incident on a plane mirror. Okay. Which row shows the angle of reflection and the name of line PQ? This line PQ is your normal. And which row gives the angle of reflection? 40 degree. A is your answer. Let's further move ahead. Okay, let's see this question. The angle of incidence of ray OP on the plane mirror MN is 40 degree. Okay, so this is a mirror MN. This is your angle of incidence, that is 40 degree. Okay. The mirror is rotated through 10 degrees. Okay, so it is rotated through 10 degrees as shown by the dash line. The direction of the incident ray OP does not change. Okay, so this OP remains in the same direction. Now, if you ponder closely, the mirror was initially like this, and the normal was initially like this. These are your initial normals and initial mirror. Now, once you rotate the mirror, what will happen? Your normal will also rotate by 10 degrees like this. Your normal will also rotate by 10 degrees like this. Okay, let's do one thing. Let's make it like this. Oh, yeah. Your normal will also rotate by 10 degrees. Okay. So now what will be your angle of incidence? Now this is your normal. This thing is your normal. 1 second. This thing is your normal. Okay. What will be your angle of incidence? This angle. That is 50 degrees. How do I know that? Because if your mirror is rotating by 10 degrees, your normal will rotate extra by 10 degrees as well. So already the angle of incidence was 40, add another 10, this becomes an overall 50. C is your answer. Let's further move ahead. Which characteristics describe an image formed by a plane mirror? Virtual and upright. Another word for upright is not inverted. Simple as that. Let's further move ahead. The diagram shows light incident on a straight edge of a semicircular glass block after passing through it. Which diagram shows refraction and an angle of incidence equal to the critical angle of the glass? Okay, so if we have critical angle of the glass as our incident angle, what will happen? what will happen? We will have the refracted ray pass through the surface. So A can't be my option, B can't be my option, D can't be my option. If you can see here, if this angle of incidence is equals to the critical angle, then my ray will pass through the surface like this. Simple. Let's further move ahead. A ray of light passes into a block. It travels through the glass block and then emerges into the air. Okay. Which angle is the angle of refraction at the surface xy? Okay. What is your angle of refraction at the surface xy? The angle of the incident ray with the normal is known as angle of incidence. This is your eye. And the angle of the refracted ray with the normal is known as angle of refraction. D is your answer. Let's move ahead. Light refracts from a liquid into a region as shown, okay, into air as shown. Okay. The refractive index for light moving from air to liquid is this 1.4. Okay. What is the angle of incidence in the liquid? Okay, we have to calculate the angle of incidence in the liquid. We have to calculate this value I. Can I calculate angle of refraction? Yes. This angle of refraction will be equal to what? 58 degrees. How did I know that? This total angle is 90 degree. 90 minus 32 is equals to what? 90 minus 32. If I place in here, this will come out to be 58. Okay. 90 minus 32 is equals to 58 degree is your angle of refraction. Okay. Now, how can I calculate incident angle? Any ideas? Do you remember the formula for refractive index? You can see we are given the refractive index of what? If you can see, we are given the refractive index of the liquid. And liquid is the first medium. The medium in which the ray starts is known as the first medium. The medium in which the ray ends is known as the second medium. Okay. So liquid is your first medium. Okay. If liquid is your first medium, then your refractive index formula is something like this: sine R over sine I. What is your sine R? Sine 58. What is your refractive index? 1.4. Sine 58 divided by sine I. Sine I is equals to sine 58 divided by 1.4. Okay, let's calculate that. Sine 58 divided by 1.4, and then you take a sine inverse. Your answer comes out to be 37.3 degrees. B is your answer. Now, some students might get confused here and will ask me in the comments that, sir, why have you taken this formula? Always remember, if we have to calculate the refractive index of the first medium, we use this formula. And if we want to calculate the refractive index of the second medium, which formula will we use? We will use n is equals to sine I over sine R. Simple as that. Nothing complicated. Let's further move ahead. A ray of light R is incident on a water to air surface with an angle of incidence theta. Theta is less than the critical angle. Okay. Which statement describes the subsequent path of R? Okay, what will happen to the path of R as it is moving from water into air, that is from more dense material into a less dense material? Okay, let's see that. It travels back into the water. No, no, A and B cannot be an option. It travels into air with an angle of refraction greater than theta. Yes, C can be my answer. Because always remember, as you go from more dense to less dense, what happens? You bend away from the normal. So this angle of refraction, will be greater than theta. Okay, let's see this. The diagram shows a ray of light incident on the boundary between two mediums W and X. Okay, the mediums have different refractive indexes. Okay, W has a different refractive index, X has a different refractive index. Some light is reflected and some passes along the surface between the two mediums. Okay. Angle y is greater than z. Okay. Which statement is correct? Okay. So right off the bat, I can see total internal reflection is happening. And for total internal reflection, it is important that you are moving from a more dense medium into a less dense medium. Okay. So if X is more dense, then X has a greater refractive index. If X is more dense, that means X has a greater refractive index and W has a lesser refractive index. Okay. Let's look at the options. Which statement is correct? W has a greater refractive index? No. W has a greater refractive index? No. X has a greater refractive index? Yes. And angle Y is equal to the critical angle? Yes, this could be possible. Because if this is angle Y, this will also be equal to angle Y. And at this angle, you are seeing a ray that is along the surface. Yes, so C can be my option. Let's further move ahead. Light enters a glass block at an angle of incidence I and it produces an angle of refraction in the glass. Okay. This is less dense and this is more dense. Okay. So if you are moving from less dense to more dense, what happens usually? If you are moving from less dense into more dense material, what happens usually? You bend towards the normal. Now, mathematically or numerically, what does bend towards the normal means? Bend towards the normal means that the angle of incidence is greater than the angle of refraction. Okay. If angle of incidence will be greater than the angle of refraction, sine I values will be greater than sine R values. Let's search for an option like that. A is your answer. Can you see at a value of sine I1, we have a sine R of 0.6 or round about 0.7. Let's further move ahead. A swimming pool is lit by an underwater light. Okay. A ray of light is incident on the water surface. What is the correct path for the ray of light? Okay. So if you want to light up this area, what will you ideally want? If you want to light up this area, what will you ideally want? You will want the light to strike the surface and to get reflected inside so that the light remains inside. The pool gets enlightened. So C is your option. Let's further move ahead. A ray of light strikes a plane mirror at an angle of incidence. This okay. The angle of incidence is increased by 25 degrees. If the angle of incidence is 25 degrees, the angle of reflection will also be 25 degrees. Okay. So the ray will be something like this, and like this. 25 degrees. This will get reflected like this. This will also be 25 degrees. So, what is the new angle between the incident and the reflected ray? The new angle between the incident and the reflected ray is this complete angle. That is 25 plus 25, that is 50 degrees. Let's further move ahead. The speed of sound in air is this Ca, the speed of sound in water is Cw, and the speed of sound in ice is Ci, I guess. Which relationship is correct? Okay, which relationship out of them is correct? We know that the speed of sound in solid is the greatest, then it is in liquid, then it is in gases. Okay. So, can you see any option like that? The speed of sound in air is greater than ice? No. The speed of sound in air, that is gas, is greater than liquid water? No. The speed of sound in ice, that is solid, is greater than water or liquid? Yeah, that's correct. Which device uses total internal reflection, magnifying glasses, optical fibers? B is your answer. The student reads the following in her physics book. The incident angle is greater than 42 degrees, which is the critical angle for glass in air. If the incident angle is greater than the critical angle, what happens? Total internal reflection. D is your answer. Let's see this. Light traveling in glass is incident on a glass air boundary. The angle of incidence of the light is greater than the critical angle. Okay, so the angle of incidence is greater than the critical angle. Okay. Which arrow shows the direction of the light after it is incident on the boundary? Okay, which arrow shows the direction of the light after it is incident on the boundary? Okay. So, if total internal reflection is happening, and as we can see, angle of incidence is greater than critical angle, then total internal reflection will happen. If total internal reflection happens, what will happen? This angle of incidence will be equal to this angle of reflection. B is your answer because B seems the correct angle of reflection. A doesn't seem the correct angle of reflection. C and D cannot be your options. Okay, let's read out this question. Light strikes the top surface of a glass block at an angle of 15 degrees. Okay. What will your incident angle become? 75 degrees. Okay. As shown, the refractive index of glass is 1.5. Okay. You have the refractive index of glass, that is your second medium. Okay. Do you remember the formula for refractive index of second medium? Yes. Sine I over sine R. What is your refractive index? 1.5. What is your sine? 75 divided by sine of R. Sine R is equals to sine of 75 divided by 1.5. R is equals to sine inverse sine 75 divided by 1.5. Can we calculate this answer? Sine 75 divided by 1.5 and take a sine inverse. This comes out to be 40 degrees C is your answer. Let's further move ahead. A solid plastic cylinder is immersed in a liquid with a refractive index of 1.4. Okay, so the liquid has a refractive index of 1.4. Light is traveling in the plastic cylinder, strikes the inside surface at an angle of incidence 40 degree. Okay. The light undergoes total internal reflection. Okay. So if this is going undergoing total internal reflection, I know that this is more dense, this is less dense. Why? Because if the light is going from more dense to less dense, then only you bend away from the normal. And if you increase the angle greater than the critical angle in this scenario, you will perform total internal reflection. Okay, so the critical angle in plastic is less than 70 degree. Okay, A and B will get cancelled out. And the refractive index of plastic, that is this, is greater, this thing. This refractive index of plastic is what? Greater than 1.4. Because more dense materials have a greater refractive index. C is your answer. Let's see this. The ray of light is incident on the surface of a glass block. The diagram is not drawn to scale. The refractive index of glass is 1.5. Okay. The angle of refraction is R. The angle between the refracted ray and the light takes with the glass block is D. Okay, so this is angle D, this is angle R. Okay. The refractive index of glass is 1.5. Let's first of all calculate this value of R. Okay, how will we do that? Very, very easy. We know that the refractive index of second medium is equals to what? Sine I over sine R. What is N? 1.5. What is sine I? 36. What is sine R? We don't know. Let's place it here. Sine R is equals to sine 36 divided by 1.5. Okay. Sine 36 divided by 1.5. Sine inverse. Your answer. This comes out to be 23 degrees. R is equals to 23 degrees. B and D will get cancelled out. Now you have to calculate D as well. How will you do that? You know that if this angle is 36 degree, this complete angle will be 36 degree minus the value of R, that is 23 degree. This comes out to be what? 13 degrees. D is 13 degrees. C is your answer. Let's see this. A ray of light in a transparent medium of refractive index 1.8 is incident on the surface as shown. Okay. Light enters air. Okay. What is the angle between the refracted ray and the normal in the air? Okay, a very, very good question. We have to calculate the angle between the refracted ray and the normal in the air. Basically, we have to calculate what? We have to calculate this angle of refraction. Okay, let's see. A ray of light. Okay, the refractive index of the transparent medium is 1.8. Okay, so we are almost given everything. We are given the refractive index of the medium, that is 1.8. Okay. And the medium is the first medium. So which formula of refractive index will we apply? N is equals to sine R over sine I. What is N equal to? 1.8. What is sine I? Sine of 30 is equals to sine of R. Let's do that. Sine of 30 into 1.8 into sine inverse This gives you a value of what? This gives you a value of 64 degrees as your angle of reflection or R. A ray of light travels from X to Y along an optical fiber. The angle of incidence at Y is greater than the critical angle. Okay, the angle of incidence at Y is greater than the critical angle. In which direction does the ray of light travel after reaching point Y? Okay, in which direction does ray of light travel after reaching point Y? Okay. So at Y, you are having total internal reflection. So the angle of incidence must be equal to the angle of refraction. C is your answer. That is reasonable, I would say. C is your answer. That is, I would say, reasonable. Let's further move ahead. The diagram shows light traveling through a medium. Okay, so medium is this. This is the vacuum. The light reaches the boundary with the vacuum as shown. The light emerges along the surface. Okay. What is the refractive index of the medium? You have to calculate n of the first medium or the refractive index of the first medium. Okay. How will you do that? First of all, draw a normal. This becomes your angle of incidence, that is 30 degrees. And this becomes your angle of refraction, that is 90 degrees. Okay. So you have to calculate the refractive index of the first medium. What will you do? You will say sine R over sine I. What is sine R? Sine of 90. What is sine I? Sine of 30. Is there any option like that? C is your answer. Simple as that. Nothing complicated. Always remember for the first medium, you apply the formula of what? Sine R over sine I. If you have the second medium's refractive index is given, then you say sine I over sine R. Okay, let's further move ahead. Which diagram represents the reflection of light along an optical fiber? Not A. Yeah, B is correct. Not C, not D. Let's see this. The diagram shows white light entering a prism. Okay. What happens at point X and what is the color of the light that strikes the screen at point Z? Okay. So, what is happening at X? At X, dispersion and refraction is happening because light is splitting into its color, and as you are going from air to glass, you are going from less dense to more dense material, so refraction is also happening. A and D gets cancelled out. At point X, you will see a light that bends the least. You will see a light that bends the least. Which is that color? That color is red. C is your answer. Let's further move ahead. An object O is placed in front of a lens. Okay. The ray diagram shows the path of two light rays that start from the tip of the object. Okay. Which point P or Q is a principal focus and what type of image is formed? So, how can we calculate the principal focus? Very, very easy. From the diagram, you can see this is a diverging lens. This is a diverging lens. In a diverging lens, if you extend this line, in a diverging lens, if you extend this line, you will get what? If you extend this line, it will pass through the principal focus. In a diverging lens, if you extend this line that is parallel to the principal axis, you will get an imaginary line that passes through the principal focus or focal point, you can say. So basically, it is a property of diverging lens that if you have a line that is parallel to the principal axis and it hits the diverging lens, and if you extend it backwards, it will pass through the focal point. It is roughly passing through point P. C and D will get cancelled out. What type of image will be formed? The image will be formed somewhere here. As you can see, the two rays are intersecting here. The image will be virtual. B is your answer. Let's further move ahead. Which ray diagram shows the action of a diverging lens? Okay, which ray diagram shows the action of a diverging lens? Not A, not B, not C. Yeah, D is the correct answer. Let's further move ahead. Which distance is equal to the focal length of the lens? Okay. So what used to be the focal length? Focal length used to be the distance from the optical center to the focal point. This is the optical center. What is the focal point? Focal point is the point through which rays parallel to the principal axis pass. This is your focal point. This will be your focal length OF, or you can say LX. B is your answer. A piece of paper torn from an exercise book is shown. Okay, which process is being described? The object is further away from the lens than the focal point. Okay, so it is beyond F. Okay, and the image is upside down. Basically, the image is inverted. This is a typical description of a converging lens. The formation of real image via diverging lens. No, no diverging lenses will be used. No virtual images will be used. D is your answer. Real image and using a converging lens. In which optical instrument is the distance between the object and the lens less than the focal length of the lens? So basically, in which optical instrument do we place the object between the optical center and focal point? In which object do we place the in which scenario, or you can say optical instrument, do we place the object between optical center and the focal point? Camera, no. Magnifying glass, yes. Always remember, for a magnifying glass, we place the object between the optical center and the focal point. Let's see this. Two rays of light pass through in region X. What type of lens this is? This is a diverging lens. A and B get cancelled out. The image form will be a virtual image. Always remember, diverging lenses form which type of a image? Diverging lenses form a virtual image. Simple as that. White light enters a prism and forms a spectrum. Okay, the ray in the air are labeled. Which diagram shows how the white light is dispersed by the prism? Okay, so how will the white light be dispersed by the prism? First of all, refraction will happen in the prism, and then it will spread out when it exits the prism. And obviously, red will bend the least. C is your answer. Let's see this. Okay, so an object of height 1.5 centimeter is placed in front of a converging lens of focal length 2 centimeters. The arrangement is shown on the full scale diagram. Okay. What is the linear magnification produced by the lens? We have to calculate the linear magnification. Okay. To calculate the linear magnification, what do we do? To calculate the linear magnification, what do? We take the height of object, we take the height of object divided by the height of the image. We take the height of object and divided by the height of the image. So let's see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the image is getting covered 15 boxes. How many boxes will the, sorry, what have I written here? For linear magnification, you will do what? Height of image divided by the height of object. Really, really sorry for the previous few seconds. Okay, so the image has a height of 15 boxes. What will be the height of the object? 1, 2, 3, 4, 5, 6, 7, 7.5. Divided by 7.5, your linear magnification is 2A is your answer. A converging glass lens is used to produce a virtual magnified image. Okay. Converging glass lens. So A and C get cancelled out. And if you want to form a virtual and magnified image, can you see in option B, you are forming a real and inverted image? B also gets cancelled out. D is a remaining option. And your image will be formed somewhere here. Somewhere here. This will be your image with this option D. Let's further move ahead. Which diagram shows the action of a converging lens on a parallel beam of light? Okay, so if you have beams of light that are parallel to the principal axis, they will pass through the focal point. D is your answer. What is a feature of red light compared with that of violet light? A prism deviates red light more. No. Red light has a lower frequency. Yes, B is your answer. The lens in the diagram produces an image of the object O. Why is this not the ray diagram for a photographic enlarger? Okay, for photographic enlarger, the image is real. Here you can see the image is virtual. So this can't be a photographic enlarger. The ray diagrams X and Y show two ways in which a thin converging lens produces an image that is larger than the object. Okay. So this is option X, this is option Y. In option X, you have a image that is virtual and magnified. In option Y, you have an image that is real and magnified. Where will we use option X in magnifying glasses? Where will we use option Y in projectors? B is your option. Let's further move ahead. In the diagram, a convex lens forms an image of an object O. Okay. The diagram is not drawn to scale. Okay. What is the focal length? The focal length is the point from the optical center to the focal point. How do I locate it this at as the focal point? Because the ray parallel to the principal axis should pass through the focal point. 20 centimeter is your focal length. B is your answer. An object is viewed from a converging lens. Okay. The diagram shows the path of two rays from the top of an object to an eye. Okay. How does the image compare with the object? Okay. How will the image compare with the object? So the image is formed somewhere here. The image is formed somewhere here. This is the object. So the image is larger. Yes, correct. It is upright as well. B is your answer. It is not smaller. It is not this. It is not this. So this marks the end of the MCQs for light and lenses. The PDF document is attached in the description below.